Hello, my viewers. Long time we have been together on a tutorial. I've just been traveling, but today I've thought of bringing a maths tutorial on probability. My name is Midhamo TK, and the channel name is Smart Traveler Memoirs. So guys, welcome to probability. So, what is probability? Have you ever wondered what the chances are of winning a game, picking a lucky card, or even passing a test? Well, that's where probability comes in. And today I will show you how to calculate probability using fun, real-life examples. Let's dive in. Introduction to probability. Probability is the branch of mathematics that deals with the study of uncertainty and chance. It measures how likely an event is to occur. It is widely used in real life, such as in predicting weather conditions, sports, insurance, and games of chance. Basic terms in probability. Experiment. A process that leads to a particular outcome, e.g., tossing a coin or rolling a die. Outcome. A possible result of an experiment, e.g., when you getting heads in a coin toss. Sample space, denoted by S, the set of all possible outcomes of an experiment, e.g., for a coin toss, S or the sample space is heads or tails. Event, a subset of the sample space, e.g., getting an even number when rolling a die. A subset is a small set picked from the whole sample space. Few events picked from a sample space forms what we call a subset. Probability theory is probability theory is widely used in areas of study such as statistics, mathematics, science, finance, gambling, artificial intelligence, machine learning, computer science, game theory, and philosophy. For example, draw inferences about the expected frequency of events. Real-life examples of probability in action. Here are some real-life examples of probability in action. One, you can do weather forecasting, where meteorologists use probability to predict the likelihood of rain, storms, or sunshine. For example, when there is a 70% chance of a rain tomorrow, lottery and gambling. The probability of winning a lottery is based on the total possible combinations. Casinos also use probability in games like roulette, poker, and slot machines. Number 3, medicine and health. Doctors use probability to assess the chances of a patient having a disease based on the symptoms and the test results. In fact, when the doctor diagnoses you, he asks questions. And from what you answer, he uses probability. Insurance as risk and risk assessment. Insurance companies calculate probabilities of accidents, thefts, or illness to determine premiums for cars, health, or life insurance. Sports strategies. Coaches and analysts use probability to decide whether a team should take a risk, such as going for a 2-point conversion in football or attempting a 3-point in basketball. Traffic and navigation. GPS apps like Google Maps use probability to estimate the fastest routes based on historical traffic data. Manufacturing and quality control. Companies use probability to determine effect rates in products and ensure quality control. And finally, stock market investments. Investors use probability to assess risks and predict potential returns when investing in stocks or mutual funds. Now, let me pick 3 of the points I've given above there, and I'll pick weather forecasting because weather is very important. In other words, I want to elaborate it more, and we say here that meteorologists analyze past weather patterns and real-time atmospheric data to predict weather conditions. Example, if a forecast says there is a 70% chance of rain, it means that out of 10 similar weather conditions, it rained in 7 of them. What is the impact? It helps people decide whether to carry an umbrella, to schedule outdoor activities, or prepare for storms. The second one I'll pick is lottery and gambling. Lotteries rely on probability because each ticket has a chance of winning. Example, in a 6:49 lottery, the probability of winning the jackpot is about 1 in 14 million, which is extremely low. Casinos use probability to ensure the house is always wins over time. In games like roulette, even though you might win in the short run, the odds always favor the casino. Guys, get advised. Smart Travelers Memoirs. And finally, I'll pick sports and strategies. Coaches and analysts use probability to make game time decisions. Example, in basketball, a player with a 40% 3-point shooting accuracy might take more than 3-pointers if the rewards outweigh the risk. In football, that is soccer, penalty kicks analyze goalkeepers' past saves to decide where to aim, increasing their chances of scoring. Impact. Teams will use probability-based strategies to gain competitive edge. Now, let's move now to another ball game or another area of probability. And now, we are now going to what we really use to what we really use as our tools for probability. And the first one is the process of coin tossing, which is very common. Coin tossing or coin flipping or heads or tail is the practice of throwing a coin in the air and checking which side is showing when it lands in order to randomly choose between two alternatives. It is a form of sortation you sort out, which inherently has two possible outcomes. The party who calls the sign that is facing up when the coin lands wins. During a coin toss, the coin is thrown into the air such that it rotates edge over edge an unpredictable number of times. Either beforehand or when the coin is in the air, an interested party declares heads or tails, indicating which side of the coin that party is choosing. The other party is assigned the opposite side. Depending on custom, the coin may be caught and inverted or around to land on the ground. When the coin comes to rest, the toss is complete and the party who called correctly or was assigned the upper side is declared the winner. So we have an example there of the 10 Kenyan cent of 1980 coin during the rule of Daniel Toroitich Arap Moi, showing you the head and tail. So the end is showing you the names President of the Republic of Kenya, Daniel Toroitich Arap Moi, and the tail is showing you Republic of Kenya, 1980, 10 cents. So this is a coin, a Kenyan coin. And this is the way you toss. Can you see that man has tossed the coin up? Okay. And here we give an example of bowling, where there is a coin toss. Can you see? I think the referee is tossing. Then you have got the two teammates there waiting. USA Army General David H. Petraeus, Commander USA Central Command, gets ready to toss the coin at the Super Bowl. This number is Roman. All right. February 2009 at Raymond James Stadium in Tampa, Florida. Practice of throwing a coin in the air to choose between two alternatives. Fine with the coin. Let's go to the other gadget used in probability. And this one is a die. And die, plural is dice, but sometimes you use it as singular. It's a small throwable object with marked sides that can rest in multiple positions. Dice are used for generating random values, commonly as part of tabletop games, including dice games, board games, role-playing games, and the games of chance. A traditional die is a cube with each of its 6 faces marked with a different number of dots or pips from 1 to 6. When thrown or rolled, the die comes to rest, showing a random integer from 1 to 6 on its upper surface, with each value being equally likely. Dice may also have polyhedral or irregular shapes, may have faces marked with numerals or symbols instead of pips. and may have their numbers carved out from the material of the dice instead of marked on it. Rolled dice are specifically designed or modified to favor some results over others for cheating or entertainment. That is a die. The faces we have there, you have dots. One face is having 3, another one is having 1, and another one is having 1, 2, 3, 4, 5. English dice for various games, especially for role-playing games. You can see there is a purple, this one here, and green, and this color is orange or something, green again, and this one is in pips, this is in numbers, and various polyhedral shapes. Probability. Strictly speaking, a probability of 0 indicates that an event almost never takes place. So if the probability is 0, there are no chances. Whereas a probability of 1 indicates that an event almost certainly takes place. This is an important distinction when the sample space is infinite. For example, for the continuous uniform distribution on the real interval 5, 10, there are an infinite number of possible outcomes, and the probability of any given outcome being observed, for instance, getting exactly 7 is 0. This means that an observation will almost surely not be exactly 7. However, it does not mean that exactly 7 is impossible. Ultimately, some specific outcome with the probability 0 will be observed, and one possibility of that specific outcome is exactly 7. The larger the probability, the more likely an event is to occur. This number is often expressed as a percentage, ranging from 0% to 100%. A simple example is the tossing of a fair and biased coin. Since the coin is fair, the two outcomes, heads and tails, are both equally probable. The probability of heads equals the probability of the tails. And since no other outcomes are possible, the probability either heads or tails is a half, which would also be written as 0.5 or 50%. Real numbers, because we also have other numbers known as imaginary numbers. The real numbers include the rational numbers, such as the integers, -5, and the fraction 4/3. The rest of the real numbers are called irrational numbers, and such irrational numbers, as well as all the rationals, are the root of a polynomial with integer coefficients, such as the square root of 2, which is 1.414, with several numbers repeating after that. These are called algebraic numbers. There are also real numbers which are not, such as pi, 3.1415, and so on, where the decimals have no under the decimal point. And these are called transcendental numbers. So we have algebra numbers and transcendental numbers. Types of probability. There are three types of probability, and the first one is known as theoretical probability. Theoretical probability is based on reasoning and logic. And for example, is the probability of getting heads in a coin flip, e.g., the probability of heads equals a half. The second type of probability is experimental probability, and this one is based on actual experiments or past data. The formula is the probability of an event of an experimental probability is number of times the event occurs over total number of trials. For example, if a die is rolled 50 times and 4 appears 12 times, then the probability of getting a 4 is 12 out of 50, which is 0.24. And finally, we have the last type of probability known as subjective probability, and this one is based on institution or experience in general or judgment. For example, the probability that your favorite team wins the next match. After the types of probability, now I'll look at the probability rules. And we begin with the first rule of probability, where probability of an impossible and certain event is an event that never happens as a probability of 0, and an event that always happens as a probability of 1. Number 2 rule is addition rule for mutually exclusive events. If 2 events cannot happen at the same time, mutually exclusive, that is getting heads and tails in a single coin toss, the probability of A or B is the probability of A plus the probability of B. For example, if in a die roll, the probability of getting a 2 or a 5 is the probability of 2 or 5, which is equal to P2, or probability of 2 plus probability of 5, which is 1 over 6 plus 1 over 6, gives you 2 over 6, simplifying to 1/3. The third rule is multiplication rule, and this one is for independent events. If 2 events do not affect each other, that is, they are independent, the probability of both happening is the probability of A and B equals the probability of A times the probability of B. Example, the probability of rolling a 3 on a die and getting heads on a coin toss, P, 3, and H, is the probability of a 3 from the die times the probability of a head from the coin, and you get the probability of a 3 is 1/6, and the probability of a head is a half. When you multiply 1 over 6 times a half, the probability you get is 1 over 12. Complement rule is our fourth rule. And here, the probability of an event not happening is P not A. And it is always given by 1, which is the maximum probability, minus the probability of getting A. So the probability of not getting A is 1 minus the probability of getting A. For example, if the probability of rain tomorrow is 0.3, then the probability of no rain is 1 minus 0.3, which is 0.7. So, number 4, I will just summarize, although this is like using probability in real life, which are the discussed area. But briefly, we can look at these 5. Weather forecasting. Probability helps predict the chances of rains, storms, etc. Medical diagnosis. Doctors use probability to assess the risk of diseases. Games and gambling. Casinos use probability to design games. Sports and betting. Probability helps in predicting match outcomes. And business and stock market, investors use probability to estimate risks. So I'm just picking those ones to emphasize to you how important probability is in real life. Examples of probability. Probability is all about measuring the likelihood of an event happening. And it is used in games, weather forecast, as we have seen, sports, and even medical studies. And the formula for your reminder is P event is always favorable outcomes over total outcomes. So let's try some examples. Example 1 is speaking about from a bag. Imagine we have a bag with 10 balls, 3 red, 5 blue, and 2 green. If you close your eyes and pick one at random, what's the probability of getting a red or green ball? So the first step you have to do is identify the total number of balls. And so the total number of balls will be the 3 red plus the 5 blue plus the 2 green, and you have 10 balls. Step 2 is now you calculate the probability asked. Because you had been asked what is the probability of getting a red or a green ball, the probability of getting a red ball is PR 3 over 10, because there are 3 out of 10, and the probability of getting a green ball is 2 out of 10, which is 1 over 5, because there are 2 green balls. So there is 3 in 10 chance of picking a red ball and 1 in 5 chance of picking a green one. Example number 2 is rolling a die. Now, let's roll a 6-sided die. What is the probability of getting a number greater than 4 or an even number? Step 1, total possible outcomes is what you find. And you find that numbers on the die are 1, 2, 3, 4, 5, 6. So the total outcomes are 6. Step 2 will be find the favorable cases. Okay? Numbers greater than 4 are 5 and 6. So the probability of getting a number greater than 4, we have 2 choices out of 6, and therefore you have 1 over 3 when you simplify the fraction. Probability of getting an even number, the even numbers are 2, 4, and 6, meaning there are 3 out of 6, and therefore the probability is a half when you simplify. So there is a 1 in 3 chance of rolling a number greater than 4, and a 1 in 2 chance of rolling an even number. And that is pretty simple, right? Students looking nervous about a test. You know why they look nervous? Because you either fail or you either pass. Look at those students. They are waiting for the papers to be given. Maybe some of them, their hearts are beating, racing, all right, and so on. So, from that picture, what is the probability of passing or failing? What if I told you that a student has a 75% chance of passing a test? What's the probability of failing? Step 1, use the probability rule. The probability of passing plus the probability of failing, always 1. You cannot exceed 1 in probability. Step 2, to solve for failing probability, then it is going to be the total probability, which is 1, minus the probability of passing, and you have 1 minus 0.75, which is 0.225. And so the student has a 25% chance of failing. But don't worry, stand a hand, and you stay on the passing side. Right. Let's practice now. Luckily, what we are practicing is exactly what we are given as examples now. The format of an examination. All right? And the first practice question is that a bag contains 3 red, 5 blue, and 2 green balls. What is the probability of picking a red ball and green ball? 2. A die is rolled. What is the probability of getting a number greater than 4, an even number? 3. The probability of a student passing a test is 0.75. What is the probability of failing? So that is the way they set the questions. And the step-by-step explanation is this. The probability of picking a ball from a bag is total number of balls, as we had agreed in the bag, is 3 red plus 5 blue plus 2 green, 10 balls. Probability formula is P event is probable outcomes over total outcomes. Probability of picking a red ball is 3 out of 10. And probability of picking a green ball is 2 out of 10. Because the number of green balls are 2, and the total number of balls are 10, and the number of red balls are 3, and the total number of red balls are, and the total number of balls are 10. Rolling a die. A die has 6 sides, 1, 2, 3, 4, 5, 6. Each number has an equal probability of 1 over 6. Probability of getting a number greater than 4. The numbers greater than 4 are 5 and 6. And these are the 2 favorable outcomes. And therefore, 2 over 6 is 1/3. And the probability of getting an even number is 3 over 6, which is a half, because the even numbers are 2, 4, and 6, or the 3 favorable outcomes. Probability of passing or failing a test. We use the rule passing plus failing. Probability of passing plus probability of failing is equal to 1. And given probability of passing is 0.75, we calculate failing as P failing equals 1 minus P passing, which is 1 minus 0.75, and that is 0.25. When I say P passing or P failing, I mean P failing is probability of failing, and P passing is probability of passing. This means there is a 25% chance the student will fail. And my dear viewers, students, and all probability fans, we summarize it this way. Probability measures how likely an event is to happen. Theoretical probability is based on logic, experimental trials, and subjective institution. Probability values range between 0, which is impossible, and 1, which is certain. Key rules include addition, multiplication, and complement rules. And finally, probability is used in real life for decision making in weather, medicine, business, and many more. We conclude by saying this: probability is everywhere. Whether you are playing games or making decisions or predicting outcomes, understanding probability helps you make better choices. I have a question for my viewers. Try this. What is the probability of flipping a coin and getting heads twice in a row? Let me know in the comments. If you found this helpful, don't forget to like, subscribe, and hit that bell for more easy math tutorials from the Smart Traveler Memoirs. See you next time. So my viewers, have you finished? What is the probability of flipping a coin and getting heads twice in a row? I'm waiting for the comments for the answer. I'm waiting for you to get the answer. Fine. Let's see. The probability of flipping a fair coin and getting heads twice in a row is calculated as follows. Each coin flip has two possible outcomes, heads or tails. Since the coin is fair, the probability of getting a head on a simple flip is pH a half. To get heads twice in a row, both flips must be heads. Since each flip is independent, we multiply the probabilities. So pH, or the probability of a head followed by a head, is equal to the probability of the head followed by the probability of the head, which will be got, which is a half times a half, which is 1/4. So the probability of flipping a coin and getting heads twice in a row is 1/4 or 25%. And you smile. How does probability help in the decision making? Probability helps in the decision making by allowing individuals to assess risks, predict outcomes, and make informed choices. And here is how. Risk assessment. It helps evaluate the likelihood of different scenarios occurring, aiding in minimizing potential losses. Data-driven decisions. Businesses, doctors, and policymakers use probability to analyze data and make evidence-based choices. 4. Everyday choices. From deciding whether to carry an umbrella or choosing a route with less traffic, probability influences daily life. Finance and investment. Investors use probability to assess market trends and potential returns before making financial decisions. And finally, medical diagnosis and treatment. Doctors use probability in tests treatment to determine the best course of action for patients. So guys, that wraps up our discussion on probability. From predicting the weather to making informed choices, probability is all around us. I hope this video helped you understand its importance in daily life. If you found this helpful, don't forget to like, share, and subscribe for more insightful tutorials on mathematics and biology. Also, let me know in the comments where you have noticed probability at work in your life. Thanks for watching, and see you in the next video, which will be a biology tutorial. I would like to express my gratitude to the resources that helped me create this video on probability. Special thanks to Wikipedia for providing valuable foundational information. ChatGPT for assisting with content structuring and refinement. And PowerPoint, which I personally use to design the virtues and slides. Your support and tools made this video possible. Thank you, guys. I don't take it for granted when you watch my videos. Goodbye and see you next time.